Hello and welcome to the Cloud Multiplier. I am your host, Gurney Buchanan, as always, and I have the absolute joy to welcome my usual co-host, Joydeep, here, as well as two amazing guests, Nick and Frank, today. So we have an amazing topic today that slots in right after what we've been talking about lately. When we talk about distributed computing, computing getting from your data center to someone else's data center and now to a cell tower or a satellite or a device out in the field or a small Raspberry Pi in your closet. And that's what we're here to talk about today. But that's a little bit of a spoiler. First, let's go around the room and talk a little bit about my co-host and our guests. So, Joydeep, how have you been? Important question, how is the weather on the West Coast? Because here, fall has finally set in.
It's cold today. Okay, let me check. It's somewhere around low 50s, mid 50s. It's been raining in the West Coast, so that's a pleasant change. But I am pretty sure in November, I'm pretty sure it will get warm again before it finally gets our West Coast cold. Right?
Okay.
But yeah, since you asked me an open question, I've been playing a lot around streaming analytics. And the thing I would like to tell the Kubernetes folks, if they have not checked out Spark on Kubernetes, better check it out. You know, if you have run Spark earlier with the Yarn Manager and things like that, you will be in for a wonderful surprise. Kubernetes makes it, Spark has now changed and it is very easy to run it on Kubernetes. So that's my latest plaything. That's my latest start.
Yeah, in the pre-show last week, you mentioned something. Isn't there a Spark operator now that you can install?
There is a Spark operator actually from Google. It worked somewhat. I should be very careful because this is public, but I got stuck in a way. I got stuck in between and I have not tried to debug. But yes, there is a Spark operator from Google, which is beta. But, you know, even that aside, Kube scheduler now actually can schedule Spark drivers and executors. That's a huge boom. That's really
cool. Yeah, and that's really good for analyzing all of the analytics from your tens of thousands of edge devices. I'm here with
right, exactly.
Well, we can go around the room as well. Nick, do you want to introduce yourself? Tell us a little bit about yourself and what you've been working on.
Sure. Thank you for having us here. It's really a pleasure. I'm Nick Barcet. I run a small team reporting to our CTO. The name of the team is a customer-led open innovation team. What we do is we connect people like Frank to real users of technologies he's working on.
That's super cool. Frank, you want to tell us a little bit about what you've been working on then, and maybe if you can talk to us about some of the cool customer use cases as well. We're here for that, but we have a whole show.
Yeah, absolutely. How much time do you have? Well, my name is Frank Zdarsky. I'm a senior principal software engineer at Red Hat. I'm actually leading edge computing in Red Hat's Office of the CTO. I've joined Red Hat, when was that? 2014, coming from the telco space. So originally I've been leading engineering work to enable first, OpenStack and later on OpenShift for telco workloads, 5G base stations, core networks, etc. And that is actually also edge computing infrastructure, right? If you think about cell towers and rooftops, etc. And through that, I kind of gradually expanded into the edge computing space. And I had to solve the problem that we had so many different pockets in Red Hat talking about some edge computing use case, and we had to tie them all together and agree on a common vision and language, etc. Yeah, so that's what I'm doing. I'm leading this edge computing team. We're looking into different emerging technologies, latest of which was the MicroShift project. And I'm going to mention a few use cases later on.
That's incredible. Before we kick off, I have an important question you just brought to mind. I've always been curious, as someone fairly new to the industry, I've always been curious, what does the volume of devices look like? Is there a difference between the volume of devices in 2014 that we have deployed to the field and the number of devices today? Because I know there's a 5G tower on just about every block down from my apartment. So it seems like there's more physical devices to keep track of as well.
I mean, like even before, I think it was Akamai back then coined the term edge computing. Like obviously, people had cable boxes, set-top boxes, Wi-Fi routers, right? And all of these are devices. And if you think about the number of households, you know about how many devices are out there. In terms of cell towers, like in again, depends on the country, on the population density. If it's in the US, you're talking about hundreds of thousands, right? If you're talking about China, you're in the tens of millions. Right? So quite a few out there.
Scale into capacity. That's so cool. Well, I feel like at this point, I've been promised, and I've seen a sneak preview of some of Nick's slides and Nick's presentation and some of the amazing data he has here. It now might be as good a time as ever to turn it over to Nick to start introducing us to MicroShift. And I'll also drop a link in chat, if that sounds good to everyone, to the MicroShift project as well. So I've dropped that link as well. Nick, you want to kick us off?
Of course. So one of the things I've observed is that as a community, we have the power to disrupt industry. And what Frank was just talking about is a clear example of all the work we've done in virtualization and containerization has already fully disrupted one industry, which is the telco industry. And the work we are doing right now as part of multiple communities, for example, the work we're doing in data science or on Kubernetes multi-tenancy, or on small form factor Kubernetes, or on safety compliant OSs. All this work is going to be disrupting about every industry in the world sooner or later. And that's all because there is something unique with open source. It's always the same thing that makes open source win. It's the fact that we can identify early needs and connect them with the community and have them participate in that community. Here we are talking about two small customers, no, actually quite large companies, ABB on one side and Lockheed Martin on the other one. One needs to do real-time analysis of data. The other one needs to aggregate data. Different needs, different setup. These two users had a problem that needed to be solved. And it's by connecting them to our community that we were able to move forward. And what we did was we invited them to join our Slack channel. We invited them to join our GitHub. And they were able to use, to modify, to comment, to give us feedback in real time as Frank and his team was working on the project on what their real needs were. And one thing quickly realized is that the thing they needed was, yes, they needed a small form factor of Kubernetes to be able to fit in small boxes. In the case of Lockheed, they needed something that not weigh too much, would not consume too much. And in the case of ABB, they needed something that could scale, so something that you could deploy on a very small box or on a big cluster and still use the same tooling to control all that. But in both cases, we realized that our work would not be complete if we were not combining it with something that would control the hardware, something called an operating system. And that's how we started realizing that we needed features specific to the edge in order to handle the industrial deployment that those devices require, in order to handle the safe reboot mechanism that those devices require. Because when you're deploying something somewhere in the field and there is no technician for miles and miles around, it's going to cost you a lot to have somebody come over to fix something. So you need something that will have a green boot process, verifying that not only the OS restart, but also the little Kubernetes that is on top. And that's how we got to the point where we could verify that the thing worked. And this is picture here is actually how we verified it with Lockheed. Lockheed actually verified that it worked, that it did fly. They have put MicroShift on top of a drone, one of their Stalker, and they've been using the drone to switch context while in flight. So let's take an example. Let's say you launch a drone to watch out for fires in California. But while the drone is in flight, and they can stay in the air for quite a while, there is a boat sinking off the coast of California. Suddenly, you want to reroute your drone, but you also want to switch the algorithm that is making the real-time analysis of the picture that are captured by the two 4K cameras that are underneath it. Suddenly, you want to start looking not for fires, but for people droning. And this is one thing that Kubernetes is perfectly made for, switching those context and switches on the model that is running. So once we verified that this was working, and this actually happened less than a month ago, that's when we said, okay, we can now announce that we are going to produce a product, that we are really solving a customer problem, at least one. ABB had done that verification a little bit before as well. And that's how we came with Red Hat Device Edge, which is actually a cross-section between RHEL and OpenShift. So I like to say it's a fully open source, 100% supported by Red Hat, works on ARM64 or on x86, and has a fairly low minimal footprint. And that's including OS and everything. So everything else you have on your device can be used to run your workloads. And that's what MicroShift was all about and what the Red Hat Device Edge is all about. So this is I believe, the last addition to the plan that we had built 3 years ago, which was to go from small cluster. We first decided to reduce the minimum size of a cluster from 5 server to 3. Then we enabled remote worker node. Then we enabled single node OpenShift server. And now we have Red Hat Device Edge that is enabling us to use those devices. And I believe our journey is complete from that perspective. So I'm going to stop here and let Frank dig into the guts of the project that he's been developing with his team.
This is wonderful, Nick. Can I interrupt and chime in, ask 2 questions quick?
Of course.
Okay, so one, you mentioned that in the rockets, almost rocket science case, drones. So the analysis of the image is really being done. All the AI is really running on the MicroShift device itself, right?
Yes.
Fantastic. Okay. And the second one is you mentioned in ABB.
And I can tell you why. You know, 4K video feed to transmit over the airwaves. By the time you have the picture, the fire would have already blasted all over California.
Yeah, I realize that.
Unit would be. So you really need to have on-site analysis.
Extremely real time. Whereas, of course, in industrial edge, there are cases where you have a private 5G network and you transmit. But this, you're right. You need to do it exactly then and there. And the second question was related to ABB. When they want to deploy on large clusters, do you still deploy MicroShift, or what's the thinking there? Or we move on to the other form factor?
We move on to the other form factor, and that's what they really liked about our proposal, is that we had the appropriate footprint for the appropriate size machine. They sell a solution by t-shirt size, which almost exactly matches the previous slide I showed with the various type of topology we support with OpenShift.
And as a user, I would deal with the infrastructure almost the same way.
I mean, once you're past the deployment phase for your workload, it's really identical. It's still Kubernetes, it's still OpenShift. There are a few limitations inside of MicroShift, but I think Frank is going to be touching on that.
Awesome.
Yeah, the best way to have it is to write it once and then run it everywhere.
Right.
And That way you have the same tool chain. You've taught your users, you've taught your developers the same set of tools. That makes life so much easier.
So funny thing, you were mentioning rockets. The first time actually MicroShift was really tested live was with IBM on Project Endurance. And MicroShift was a very early version of MicroShift, was inside this little small satellite that was launched by SpaceX. I think it was a year ago.
Not even, it was in May this year.
That was our first real life trial for MicroShift.
Real life trial in a rocket.
Okay, you see, time flies and I can't measure it.
Yeah, was that the news articles I was seeing about Kubernetes is now in space?
Space.
Yeah, we actually had a launch party in the team, and everyone thought like, "Hey, have you already launched MicroShift?" Well, yeah, literally, because we're all sitting together and watching the SpaceX live feed for countdown. You actually see that in the bottom right corner, right? That's actually the Transporter 5 mission that shot up MicroShift into space.
That's amazing. That takes over-the-air updates into a whole nother category, I think.
That's exciting.
That's amazing.
Go ahead.
All right. Maybe just a little bit for context, because Nick already mentioned it before, that we have all of these different footprints at the edge, and the reason is because the use cases are just incredibly diverse, right? We briefly talked about those cell towers. We have telco customers basically deploying these single node OpenShift servers on rooftops, and those rooftop cabinets running 5G cell towers. And in that case, they really care for the kind of small quotes footprint. It's still a beefy server, right? It's a high-end server with FPGA acceleration and network acceleration and all that stuff. But it's a single server. And then you would wonder, like, why would I deploy a single OpenShift server? And the reason is because it's actually a workload that can fail, right? If a base station goes down, neighboring base stations can compensate. And so basically, the OpenShift team invested a lot of time to cater to all of these different use cases. There is a class of use cases, though, that they could not address, and that's because we're not talking about a server world, but about a world of devices, what we call the device edge. And I just show 4 examples. Nick mentioned the ABB use case, which is an IoT gateway use case. The Lockheed one is on drones. Actually, there are these future 5G radios, which are these tiny dots that you put in the ceiling just to get better indoor coverage. And then Nick also already mentioned the endurance mission, right? So MicroShift on satellites. And really, it is about adapting Kubernetes to what's called field deployed devices, right? Devices are these single board computers or systems on chip that you see examples of to the left. And what characterizes these hardware platforms is that they are application optimized, right? If you look, for example, into the NVIDIA Jetson family of boards, they are really, really good at doing AI/ML workloads because they have all the kind of accelerators that you need for that on there. Of course, everyone's favorite maker platform of the Raspberry Pi is there, right? We have the Xilinx UltraScale, which is really good for like signal processing workloads, and the NXP platform for media and kiosk type of applications. But what also happens is that these are really limited in resources, right? You buy them with 4, 8, 16 gig of RAM, and later on they're not extensible because they have all I/O, all the resources and accelerators that you need for the use case already on board. And what also happens is that they are typically ARM-based, and unlike servers, which have like certain hardware and firmware features that are standardized, that makes it really easy for the operating system to light them up. These devices are not very standardized in terms of firmware and hardware features. And the other part is that are deployed in a server room or cabinet or some other controlled environment, but they are deployed somewhere out in the field, right? Can be, extreme case, of course, on a satellite, but can be like along an oil pipeline, right, for critical infrastructure. It can be on a train. It can be whatever. And the consequence is you have to deal with all kinds of additional constraints in addition to footprint, right? You have to deal with constraints in power, because maybe these devices are battery or solar powered, or they have an unreliable power source. Somebody may just pull the plug accidentally because they need to vacuum, right? There are constraints in thermal design power, right? So they say on the satellite, what do you do with all the excess heat, right? Networking. Typically, you may be mobile. Your IP address changes. You may be behind the net. You may be connected via satellite, so you're paying by the megabyte, right? Security, there's no physical access security. People can touch the box and manipulate it. And so there are all kinds of additional constraints coming from that. And the other part is think about how devices are actually deployed, right? When you buy, I don't know, your Wi-Fi router or your smart home assistant, whatever, you basically just order them from your favorite electronics supplier, you unbox them, you plug them into the wall, and maybe there's like this app that allows you to take ownership of that thing, right? It's not like a server that you install using ISO or whatever. And of course, you also don't have any out-of-band management. There's no IPMI, right? There's not even a technical person on site when these things are deployed. And that's where Nick already alluded to. When some of those things break, they're not recoverable remotely. Right, so it's a very different type of use case. That's what I was trying to get at, and the consequence is you really need something that's optimized for this kind of use cases. And really, to appreciate what this Red Hat Device Edge is, let me just briefly unbox that. It's really well, right, but with a very small footprint and based on and using an image-based model instead of a package-based model. Plus then it has several features and tools exactly catering to the device edge, right? Why is it image-based? Well, think about your mobile phone, right? When you update the mobile phone, what happens is that, your mobile phone's vendor, they basically create an image of the whole operating system, the driver and the core applications in your system, right? And then they create a golden image of that they can then version, build, test, and deploy as a unit, right? So giving you very high reproducibility. So that's what Red Device Edge does. It's also on the build your own system model, because we need customers to be able to embed drivers or configure the networking packages or whatever as part of the system image they're building. It also supports so-called A/B deployments. So what you can do is, while your system is running, you basically already download the new version of the system, operating system drivers, applications in parallel. And only once everything's verified, then you can lose network connectivity. And still, you would be able to safely update. The actual update is actually just a reboot that takes seconds, and bam, you're on the new version. But it also allows you to flip back the switch and say, hey, something went wrong. I need to go back to the old version. You reboot, and seconds later, you're at the old version. And then there's this green boot that Nick mentioned, which is basically just a health check to say, these are the conditions under which I consider my device healthy, my update healthy. If not, roll back. There's things like FIDO device onboard. It's an industry standard to which Red Hat also contributed, and we've implemented actually like a reference implementation or production grade implementation of this, which gives you this behavior of, all devices are equal. You plug them into power, they come up and they automatically securely identify their owner and get under management. And of course, that runs RPM container and VM workloads like every RHEL, right? And the key part here is it now also runs Kubernetes workloads, because of MicroShift. And just to briefly discuss, why would you do MicroShift on these small things? Well, a lot of the users, they start out with RPMs. They don't even care for containers, right? Because they come from a world where they're used to, things called like Yocto or build root tool chains. They're basically building all their systems from source, like Gentoo users, right? And eventually then they realize, hey, I need to maybe containerize because I have multiple application development teams working in parallel and I don't want to create dependencies. So they do that. And they deploy 2, 3, 4 containers. And sooner or later, they realize, hey, I am deploying so many services there, I need some form of orchestration. And then they start scripting and they're thinking like, whoa, okay, that's wrong, right? As soon as you say, I need to handle software lifecycle of many different services, you suddenly need orchestration. Maybe you want to deploy off-the-shelf Kubernetes workloads. Maybe you want to standardize, the same dev and ops model on your devices as you have on other edge or cloud footprints, right? Or maybe you want to leave the path open to grow and become HA or multi-node or whatever. And that is exactly where we're saying, well, maybe you use MicroShift and whenever you're ready, just deploy MicroShift on that node, and suddenly you have the ability to run all of these Kubernetes applications. And you actually have 2 models. That's why I'm trying to get at this in this figure. The first model is, you can embed your Kubernetes applications into that system image. So when you boot the system image, you immediately have all network applications, all applications available without any network, right? It's like the default applications on your phone. Or you can use it as a traditional container host and dynamically add and remove applications like you would do on an app store, right? And both of these models are supported because the use cases are so diverse. And we actually intentionally chose to build MicroShift on top of this RHEL with all these edge features because we're lazy, right? They already solved a lot of the problems for us. And all we needed to do is really provide an RPM package that you can add to the system image, and that's it, right? And so just very briefly, conceptually, when you contrast it to OpenShift, what OpenShift on the left gives you is kind of this full vertically integrated thing, right? Where the operators on OpenShift take you to kind of full autopilot, if you want, right? They take care that you can update the cluster, that you can update the operating system and the configuration of the operating system, that all the extension cards you can put into servers like GPUs, networks, they're all managed for you across the whole cluster. MicroShift is different. It doesn't do any of the operating system and configuration management. It's for system builders to say, I know how to configure my network, right? I basically design my operating system to the needs of my device. And then you just have this small runtime that you install and you can run Kubernetes workloads. And once you do that, again, you can put whatever management, for example, ACM, right, on top and get the same behavior of deploying applications and monitoring your applications afterwards. And that's what I think is so nice about it. Let me stop here because it took more than we discussed.
I was going to say it's almost the benefit here is you don't have to reinvent any wheels coming from a Kubernetes world. You get all of that robust use case of, hey, I can run applications, I can have my containerized applications here, but you get the same assurances in a device. Compare it to your home router. You expect to be able to unplug your router and plug it back in and have it power back on and start up that application that you can dial into and say, I want to change settings, and it'll start up the routing appliance and start routing packets again, and you expect that to happen. And that way that can be, a containerized application or whatever. You get that nice pluggability, that you get all the assurances needed for edge, but you don't have to compromise on how you run your applications. And I think that's that's truly amazing. As someone who's had to run workloads on all sorts of different topologies and adapt and hack different applications to run on CI systems or job runners or application platforms, to have one where I can take my application to MicroShift and my application to OpenShift and my application somewhere else and have the same tool chain, the same tool set, that's incredible. And then I'm sure Joydeep's about to say something about how amazing this is for monitoring and data applications and understanding the status of everything.
Yeah, thanks for that, T. But before we go there, Frank, so do I interpret it as if you don't need to deploy Kubernetes applications on the fly, etc., then the fleet manager can manage the application lifecycle as well as the device lifecycle of MicroShift?
So the fleet manager is what you would traditionally call a device manager, right? So it is the one that takes care that a device that gets onboarded using, for example, FIDO device onboard becomes part of the inventory, that you can actually introspect it, right? That you then can say, update into this version of the system image, right? So it's all about managing the operating system and its configuration. If you embed RPM workloads, they are part of the system image. So yes, you include them, right? If you want to add Podman containers, or if you want to kind of bake your Kubernetes applications with MicroShift into that system image, then yes, you would use the fleet manager, right? And then maybe ACM to do the Kubernetes-specific monitoring of the workloads.
Right.
But you can also say, I don't want to bake the applications into the system image, right? I just want devices where I can load one application one day and another day another application, and you can basically just use again ACM to
do that,
pull in the workload of the day onto your device, right?
And that ties to what Nick was. Sorry to cut you off. Finish up.
No, please.
No, I mean that would tie to what Nick was saying earlier. If I'm ABB and if I'm running large clusters, I'm running the things on the left-hand side of your drawing, and if I'm running MicroShift, I'm running on the right-hand side. But the experience for me as a customer remains more or less the same.
Exactly. Yes. From ABB's perspective, it means they develop the same application workload, and then they basically say, I can have all T-shirt sizes of my portfolio running the same workload. Right?
This is fantastic. And
yeah,
go ahead, Garni.
Do you see a similar use case in the industrial space as well? Because I can imagine a case where you might want to have MicroShift in your core OS and a few core applications that connect to a large network in, say, a manufacturing facility, but then have applications that are specific to the appliance that's currently being used with this embedded device. Is that a use case that this is targeted at, or something different?
It's really about, understanding that there's kind of a hierarchy or tiering of use cases, right? If you have a factory floor that where you need to run some logistics system or some whatever data analytics, you will probably have some form of server cluster, right? That takes care of that part. If you have a how do you call that? Robots roaming over the shop floor, to basically deliver goods, that could be running MicroShift, right? And it reports to that factory floor cluster, when then you aggregate high-level data and send that to the cloud for this overview across multiple facilities, right? Or you maybe collect data, send it to the cloud for machine learning, for retraining, right? And then you basically push the models again to the edge. So it's really understanding that the power of edge computing is that you basically run compute where you need it, but that you have this consistent experience, right? So you need to update your application. You probably need to update it in the cloud, at the factory central cluster, but maybe also on the devices. And if now all of these deployments were using different technologies, different approaches, then it would be really, really cumbersome.
Yeah, that's actually what's happening. I mean, industry has been using so-called edge computing for decades. Steel plants, rolling mills, paper plants, they all have very interesting stuff running at the factory floor. But what the whole Kubernetes and this formalized approach does is it tries to make that all work the same way. I mean, that's the goal. It will take a long time before the entire frame can be fulfilled, but this is huge. And everybody, I mean, people are jumping into the Kubernetes bandwagon, right? People are using containers. People are seeing the benefit of that, tangible. And people do understand the benefit that OpenShift brings into managing all of that. So, yeah.
On the other hand, there's also a lot of brownfield, right? I mean, skills where teams that just do not yet have any container or Kubernetes skills, right? Because they have a different background. So how do we build bridges for those? How do we ensure that you can gradually roll out these new technologies, right? And get teams to collaborate because they are using common tool chains, a common language, if you want.
Yeah, I've been in the development operations space for a while, and that's one of the hardest problems to solve is getting it's so much easier to build the tool chains and make tooling selections. The two ways to do it seem to be, one, you are a large company and you've made a decision we're using this tool. So you decide on what tool you're going to use and you make everyone use it. And then you end up with people building adapters and building ways around it. And then there's this case where you've chosen a platform that lets everyone truly develop using the same or a very similar tool set and the same technology. And then you end up with a bunch of multifaceted experts that can move around between teams and understand each other's language to work together. And that's something amazing that I think this facilitates across the stack, from someone working in a data center in a hybrid cloud space and someone working in a distributed edge platform. I think that's amazing.
And then maybe what you also mentioned earlier, yes, I mean, edge computing has been out for quite some time, right? But I would argue back then when there was compute at the edge, it was bespoke hardware, bespoke software for a specific purpose. And I wouldn't call that edge computing, right?
I mean,
edge computing, as soon as you move to general purpose hardware, commercial off-the-shelf hardware, right? As soon as you use commercial off-the-shelf operating system, not one you built yourself, and can use all the IT cloud-like tooling, actually, to deploy new kinds of services rapidly to these general purpose footprints, if you want.
Yeah, no, I totally understand that. And when you used a very interesting word, computing at the edge versus formal edge computing. And because in the industry edge, it's all filled with proprietary hardware, proprietary network protocols, and all that kind of stuff. So we are chipping away a little bit at a time. Yes, Nick, you were going to say something?
Really important for the customer is not the fact that you're using off-the-shelf hardware. It's the fact that you're using stacks that you can interconnect. And as soon as you can interconnect, you can interject. And you can add your own AI model to take control over the machine that were black boxes to you before. Yeah. Or they were maybe not black boxes, but you could only program them one way, the way of your vendor. And you could not modify the behavior because you have installed a sensor in the other room. Or you would have to use very complicated bus to interconnect these things. And even though they were standards, they didn't work the way you wanted. So the revolution that we brought to the telco industry was really there, allowing for the same RAN, radio access network, to have different vendors taking part in different parts of that network. With Edge, we are generalizing that to many other industries. And that's really what the end user benefit is. It's the ability to recompose whichever way they want and not be forced into the model of a single vendor that they will have to follow, life and death included, because you can't interconnect it with anything else.
And that can accelerate innovation as well, because you can now, that tool on the shelf that wasn't compatible with your specific vendor 5 years ago is now a tool on the shelf built for Kubernetes that you can run on your general purpose appliance on demand. So there's that, it lowers that barrier to innovation. I think that's amazing. I worked a lot with Raspberry Pis in a past life doing some data monitoring on honeybee hives. And that was all we had very specific drivers for very specific microphones and cameras and all of these, and we were locked in. There was a pain point around that where we had to keep using the same tools because we had the hardware already. And this is a huge...
You mean honey bees?
Yes, actual bees.
Wow.
Yeah, I'll tell you about it sometime, Joy Deep. It was pretty cool.
That's interesting. Yeah, that's interesting. I worked in steel plants and rolling mills and paper products, so I mean I saw ABB Edge Genius. I knew what, in which level. This is very, very exciting, and especially this stuff. This can usher a whole slew of change in how automation, in factory floor works. This could seep in slowly and make lots of changes.
Yeah, things about what it's going to do to the industry, but also the retail world or the hospitality world.
Yeah.
What we are enabling here is really limitless.
Yes. Yeah. I mean, Frank mentioned on a train. Yeah, you can imagine the 5G stuff on the ceiling. That was very interesting. Yeah, you are going to repeat. You are going to amplify signals, so you have a small. No, the potential of this is limitless. This is fantastic, and I guess the way the uniformity kind of is enforced, that is really awesome.
And then maybe also, because RHEL is the common fabric across all of this, whatever we do in one of the industry verticals, let's say all the work we've invested into, new types of hardware accelerators that we support, or real-time kernel, or line rate networking. You leverage it across all of these industries, because on the factory floor, you start maybe with analytics, but then sooner or later you're controlling your production line, right? Because you've got the time-sensitive networking capabilities that you need, and suddenly, all of these operational technologies in the IT starts converging.
Yeah, and one thing we didn't even hit on yet, we're coming up on time, so I'll wrap us up quickly. But one thing we didn't even go in depth on is security, because I know one of the big things about appliances at the edge and about all of these appliances and all of these different workloads is security, and something that I know RHEL brings with it, and a lot of the work that's been done on RHEL to keep it secure as well. Which is amazing. So if people want to try this out, if I want to run this on my 2 Raspberry Pis that I have in a drawer, is the right place MicroShift.io to get started and get exploring?
Yeah, it definitely is, yes. So there's like a small getting started that we still... we also still need to update that. So, I mean, there's a lot of stuff in progress and moving very, very quickly right now. So, but yeah, that's a great way to start. And there's also links to... a Slack organization where you can join and ask questions and engage with the community.
Amazing. And if anyone has any issues, I'm sure I tossed up on screen, we have an email after the show too. So you feel free to email us at cloudmultiplier@redhat.com, and we can field those and connect you with Frank and Nick, or the resources that can help you out. So as always, thanks for joining the show. This has been an amazing show. Thanks for joining Nick and Frank. It's been great to talk about this, and it's been an amazing time. As always, I have one teaser for next week. In 2 weeks, we're going to be resuming our discussion about disaster recovery, which feels like a good thing to have once you've reached this sort of scale. So this is going to be an interesting one around disaster recovery for a hub cluster. So your management utilities for all of this fleet of clusters. What happens if you want to disaster recover that? What happens if you want to fail over? That'll be a really cool discussion. Hoping to get some folks on for that in 2 weeks. So we'll see you in 2 weeks. As always, feel free to reach out, and we'll play the intro as the outro.